Cheers. Before we get started, can I have a show of hands of who is sort of more on the AI side of things? All right. Not many.
On the AI side of things.
You want to be on the AI side? Who is more on the economic side of things, like knows all the game theory or micro in particular? Yeah, okay. And then like crypto is the rest, I guess. Who holds some tokens? Just checking. Okay. Yeah, thanks. Yes. Okay, so we're here to talk about autonomous AI agents and in particular how we can create entire economies of autonomous AI agents. And I was asked to talk about obviously Governator, which you brought up, and also the prediction markets. I think is very relevant because we had Bo talk about it. We had basically everyone talk about it. Robin as well. So who am I? So I'm co-founder and CEO of Valerie. Valerie is the labs, which is the core contributor to Olas, of which I'm also a founding member. And once upon a time, I did a PhD in economics, applied game theory. And what is our mission? We basically want to allow anyone, groups or individuals, to own very powerful AI, not having to pay tax to some centralized provider. And we're today building decentralized autonomous agents. I'll be covering a couple of topics, but we can be breaking out of this. If there's questions, then let's bring them on right away, because ultimately I've done this talk a couple times. I can send you the link. So if we can just kind of make sure everyone's on the same page here, that's more important. I'll talk about briefly what Olas is and why it exists, then go into some of the use cases which were already mentioned, go into this concept of agent economy, give you an example of one, and then explain you how you can go home and build your own. So that is my attempt of creating a graphic. I'm not the designer. So we have two paths, always two paths, right? Never more. The one is where basically the agents enslave us, right? So this is this kind of thing. You go on Twitter, you open it up, and then like half of Twitter will argue that soon we'll be enslaved by AGI, and we should do a lot of things as a result. Then there's the other side who will be a bit more positive about it, but actually breaks down in a lot of ways. So there's the ones who say, well, and you know, Sam is a big proponent of this, is like, well, you should trust me, I'll build a very safe one, and then you can pay some tax and access it. I think we should aim to build a safe one, and today that basically means just useful autonomous agents that complement what we do rather than replace or one day even attack us. And I do think there's a choice, but that's not the point of this talk. So why do autonomous AI agents matter more generally? I think we have like a very interesting point in time where three big trends somewhat converge. So one is the web. You all know the story: read, write, own, right? Web 1, Web 2, Web 3. Basically, own your data, own your algorithm is what Web 3 is about in some sense. If you think about AI, you can also force a classification there. It certainly started with rules-based. So basically, people came up with elegant computer-based rules, where computer code-based rules, where you basically describe the system, and it can become quite complex. And even chatbots were created like this. But ultimately, you run into like major constraints, right? And so what people figured out is that rather than have the rules be the program, let's define rules to look at a lot of data, more than we humans ever could, to come up with new rules, which are then actually the program, right? And that's a sort of learning-based algorithms. That's basically the foundations of everything. When we loosely say AI today, we're referring to large language models fall in there. But then if you go further, and if you listen to like any of the cutting-edge research on the AI side, everyone wants to build agents. And it's kind of obvious, because if I have agentic AI, well, it's going to be more valuable than just AI, which I can call like ChatGPT, right? ChatGPT doesn't do anything if someone doesn't use it. We can be sure of that, right? If someone else tells you something else, probably smoked something. But that's where everyone wants to go to. And then in terms of UX, that's more sort of our story. You might agree or not. But I think one can argue that somewhat as the web progressed, we have also a change in interacting paradigms. So we start with viewing, right? So initially, mostly researchers put up websites, and other researchers could read them, and then that was the internet. And then we obviously had news sites and so on, and then ultimately interacting come in, and that's where it all exploded, right? Like all of us, actually, when we think about apps, I would bet the first thing which comes to mind is something where we sit there and we click on it. It's like, you know, swiping on Tinder and like whatever, your feed. But it's sort of, we're almost like conditioned now that like the UX should be one of like intense interaction. And actually we spend a lot of time as a result with these applications. But what's the cool thing? If we have agents, we can push a lot of things away from us, right? We can have a lot of things done by systems on behalf of us. And an example of this is like in the physical world, which we know for a long time, is like the microwave or the washing machine, right? But also something like a Waymo. And increasingly this comes like really to the software world in a full blow. And I would call them like sort of outcomes generators. And that's really where it becomes interesting, because clearly if we have outcomes generators that we can own, that can do things on our behalf without us having to constantly be there stoking their fires, then we have a very valuable thing on our hand. But we want to be in the bottom world, not the top one, right? So that's what we're here for. We actually have a bit of traction with this. So today we're one of the largest consumers of safe transactions on Gnosis chain with the agents in the Olas ecosystem. They're approaching to 1 million transactions, and we're on 8 chains. That's just to say that basically what I'm telling you is somewhat based in reality and not made up. And then there's basically two things, a stack and a protocol. So the protocol is what we deploy on chain on these 8 chains currently. And then the stack is what allows anyone, because it's open source, to build these kind of systems. So what are these systems? We basically, loosely speaking, allow you to build agents. I'll briefly segue into this whiteboard and explain what an agent actually is. So let's say we have here a box, which we'll call the agent. Then around it, right, there's an environment. And so what happens is, like, we perceive all sorts of inputs from our environment, because we humans are agents. And then eventually we act on the environment, right? And so a software agent, same idea. You perceive certain things. This could be via an API. It could be via some, this is a very abstract, so kind of everything can be described as an API. But let's say a sensor, whatever, like some events, whatever you want to call it. And then ultimately, well, then you have some internals. And at a minimum, you have to have a loop, right? Like that's sort of the most basic thing. You have to have some form of loop where you're like kind of iterating over something. But obviously, this can become arbitrarily complex. Like there can be, some memory where you like store certain observed things, and then there can be like, at the moment, large language models which the agent uses, and like sort of maybe the large language model might even like determine what the agent does next, and so it kind of becomes like this kind of very inherent relationship. Anyhow, these internals really depend on what you're building. And then ultimately it acts, right? And then like again, this can be like a smart contract which it calls or writes to, like reads or writes to. It can be like some server on the web, or it can be something else, like some sort of local sensor or something. Maybe it moves an arm with a robot or something. So an agent is this very generic thing, and we've built the software stack to allow you to basically create agents which are quite crypto native, which means basically that sort of out of the box there's a couple of things which are quite handy when you're building agents in a crypto context. So most importantly, one thing which we have, which some of you might know, is like this concept of account abstraction. So basically every agent in Olas has like this on-chain representation as a wallet, and then off-chain there's like this actual software instance which is running, and this allows basically the signer key to be separate from the wallet, and then you can do all sorts of cool things on top of the wallet. That's again a side topic, because it's kind of, you need to understand lots of things about actual smart contracts. So if that was a bit over your top, that's fine, over your head. Anyway, one, I think, key thing with our architecture, and by no means do you have to kind of go with our architecture, it's just one we created to unlock a couple of specific things we care about. One thing which is unique is you can create an agent where, and sorry it becomes a bit technical, where the agent itself is actually a node system. So this thing itself is basically made up of a bunch of nodes, and then they, like a blockchain, sort of communicate with each other, and then before any sort of significant state transition happens, the system will agree. And so you can have sort of this off-chain consensus thingy, which is the agent, and then you get some of those nice properties of a blockchain, right? So if like one of those nodes is down, the system will still work, but then if, let's say, two of those nodes is down, it will stop in this case. And also if one of those nodes gets attacked, that's fine, the integrity remains, because the other three will make sure that whatever actually reaches like the chain or some other API is valid. So we call these more complicated ones decentralized agents. And then the last thing which really matters, and that's where we'll spend a lot of time later, is like agents by themselves are pretty dumb in my opinion. It's kind of occasionally quite interesting to build a single agent. But really when it becomes interesting is when we have multiple agents. And I'll motivate this more later. But this is when basically you have one software agent rely on another software agent to get something done. We call it like agent economies, loosely speaking. Last point on Olas is basically, this is like an on-chain DAO, so there's a lot of ways to get involved, basically 6. If you're more curious, you go to the website and then you can learn about it. They all have a landing page with their own CTA and so on and so forth. Let's dive into this first use case, which is the governator. So we just heard this really great talk about, where's the author? Don't see him. Oh, yeah, I don't see him. Okay. We just heard this great talk about using multiple models potentially in a governance context. So we did something similar. And when you think about having an agent participate in governance, I think there's like sort of two ends of the spectrum. So one is over here where you have this kind of single agent use case. And then the other is this decentralized one. And here I'm referring to this terminology which I just introduced. And now I think there's a distinction as to which use cases are more suitable towards either side of the spectrum. So if you think about this use case where you as a user want to be represented by an agent on chain, then this can be a very useful paradigm, because basically I don't even really need any crypto other than being able to sign transaction, right? Like that's literally all I need, because if the system is fully under my control, I am very happy with running a single agent, i.e. some software, locally for instance, or on a cloud instance I trust, to do something on my behalf. So we had this example mentioned earlier inside when Matt was presenting, and then there was this question around governance. This example where a user is represented by an agent, right? And where basically the agent then goes voting. This can be very straightforwardly implemented as a single agent use case, because really, if you think about it from the perspective of a DAO, to the degree that this representation of the user and the agent is done appropriately, which is a software challenge, and we'll get to some other challenges, but largely a software challenge, you have, from the perspective of the DAO, there's no difference in terms of how this all looks. There's a signer off-chain, signs a message representing this user's wallet, bam, like you aggregate the votes, right? Nothing changed. However, let's think about a use case where we actually want to maybe represent a group of people, and or where we care much more about like the potential attack vectors which could come in if that system sort of represents a larger stakeholder in the DAO. So that's what we have here in the governator. Basically, what is the governator? We said, okay, let's build an agent where we have this agent act like a delegatee, right? So if where is he? The big delegatee here. You're a delegatee, right? So if we all delegate to you, then basically currently what we're doing is we're sort of trusting that, like basically the act of delegating to you, we're implying that we're sort of trusting what you're doing and that we are kind of happy with what you're doing, right? In the case of a software system, we could again do this to a single agent, but now we're introducing like effectively this good old problem, which is whoever is operating this agent could basically be saying they're running this agent, but they're actually running this other thing, right? And so we might want to instead say, okay, can we create some system that is a bit more like robust? And so we come back to this decentralized agent architecture. So rather than having an off-chain system which consists of a single agent, we could have an off-chain system which consists of multiple agents. And so that's what we've done. We basically utilize our infrastructure here. Also here more sort of nicely presented where you have multiple nodes. They run off-chain all the time. They embed the agent logic, and then ultimately they take action on-chain, but only if they agree. And this has a number of nice side effects, I would say, which make this even more robust than just having this off-chain consensus. Because ultimately what you're doing in such a system is that you're basically building one of those agents which under the hood has some sort of model, usually large language models at the moment, which read proposals at some point, right? Now the issue with that is that we just heard like we could ZK proof this model or run it in a TEE. That's all good and well. We now know that this compute is verified. However, we don't know whether the model is actually appropriate for what we're using, right? So the problem with large language models is, and anyone who was here for the last 3 weeks probably heard the talks from the guys from Anthropic, that no one even knows like what this thing is, right? Like you can poke it and like sort of infer some things about it, but there could be entire like weight areas or regions of, let's say, the Latin space where this model is maybe even poisoned because someone specifically trained it to be basically bad in this area, or it could just be bad in the sense of a non-malicious bad. And so the nice thing is when you have a distributed architectures, you can now rely on multiple models, right? And so that's what we're doing here. It's like rather than saying, okay, we're gonna take all these proposals, whack them into a single large language model and prompt it with something, and then take whatever that prompt says, we're effectively replicating this across a lot of different models, and then we take that, come to consensus on that off-chain, and then we vote. So it doesn't solve all problems, but actually when it comes to pure hallucination or individual models being potentially artificially poisoned for some region of the parameter space, let's say, for this particular proposal, then this could be a way out. So anyway, we've built this thing, but it has a lot of shortcomings. So it currently votes, it does on-chain, off-chain voting. That's all sort of trivial. It basically reads proposals just fine. It aggregates all this information. But where it's actually getting very, very complicated is around the preferences, right? So that's the harder part here, because you obviously need some way of saying, okay, well, there's now all these people. This system is represented by them. This system doesn't just have your opinion, right? Like we need to somehow describe that. And so one way, I think an ideal way would be to say, okay, we have some sort of preference elicitation, which each of the users do before they delegate to the system. And then we use that to basically build up like the preferences of the governator as a whole and let it act. that currently doesn't exist. So if you're interested in building this, come talk to us. The other thing, which obviously would make sense, is to think about how such a system could directly integrate with some prediction markets to either do literally what you presented yesterday, or simply just as a piece of additional information, as to help people maybe when they present, when they input their preferences or things like that. Now, I'm going to go into a different topic, and I'll come back to this. By the way, I've gone very fast, so if you have any questions, just jump in. All right, keep going.
How do the agents coordinate before going on chain?
Because you can think of them as a logically monolithic system. I mean, basically, it's like the same way your blockchain coordinates. There's a bunch of nodes. They have a defined software architecture, and they in constant communication with each other. And so whatever is defined as code on those nodes determines how they coordinate. It's a software stack, so it depends on the developer.
It's not like, okay, I said that it was one within the stack.
No. So we provide primitives for you to build kind of applications like this. But we don't say every application has to use a certain form of coordination, whatever that might mean, like in the loose sense. Okay, so now let's talk about agent economies, because when we think about these prediction markets in the context of Governate, I want to come back to this. One thing which also bugs me when I listen to like the debate around AGI and all this stuff on Twitter is that there's this implicit assumption that we all sort of going to have like one super monolithic system which we're all going to use, and therefore we should all be scared, and then we should regulate or just give up or whatever. And I think from a pure economic point of view, that's actually quite very unlikely. I mean, if you think about us as humans, any level of intelligence, it pays to specialize, right? None of us create all the goods which we're using, right? Like, it's totally impossible today anyway, but long time ago we gave up on doing everything at once, right? And so similarly with like a very smart software agent, ultimately there's like a comparative advantage you have as such a system, and it pays, literally pays, to do that over doing all the other things and let someone else do the other things. So not only in the future do I believe specialization will happen, although challenge me after this talk if you feel otherwise, I want to hear the arguments. Today it definitely happens, because today we don't have generalized, autonomous AI agents which can do anything. Like, that just doesn't exist. OpenAI doesn't have this, no one else does it, right? We just have like specialized systems which can act sort of semi-autonomously or fully autonomous in certain domains. And so when you have that, very quickly, when you actually build use cases, you'll find that it's actually even like from a UX perspective quite natural to have this specialization, because ultimately someone has to operate these agents. And these agents, like operating, in the sense of node operating. And so when you're operating these agents, depending what these agents do, the requirements could be wildly different, right? So you operate one agent, it might have like high capital requirements, the other one in the actual like money sense and like finance sense. You might have another where the requirements is to basically provide like several H100s or like other kind of like infrastructure which not everyone has just access to like this. So in the pure operator sense as well, the more specialized the agents are, the easier you'll find a market for someone operating these agents, because they can specialize on operating the agents which they have the requirements for. So we already today see like a high degree of specialization with agents, and we think this will actually continue to happen. And so if that is the case, you definitely need communication between these agents, right? And this communication can potentially happen on-chain in the sense that, agents can literally transact with each other, which is a form of communication, or like send each other messages or so on-chain, but naturally they also do a lot of this off-chain. So we have started like spending all our energy this year on basically just thinking, how do we build like massive agent economies? Like right now we have like several hundred agents. Like our goal is to get to several thousands by the end of the year, ideally tens of thousands. But like ultimately we want to be millions of agents and ultimately more than humans. And it's all about basically creating incentives such that we can bootstrap these economies into existence, which then you'll see has a whole bunch of side effects, which gets us back to the very first slide.
You know, on the agents, you said from 100 to 1,000. Is an agent just an agent that contains a different like set of agents inside it, or set of LLMs inside it, or is it they're programmed differently? What's it like? What's in the 100 set versus in the 1,000 set?
Yeah, so here I'm talking of instances rather than types. So I think the question was, if I remember like if I understood you correctly, when I'm saying number of agents, do I mean like instances or types? And I mean instances. So in the sense that like we have like, 7 billion humans, a lot of us share similar professions, right? So that's how I'm thinking about it, like literally in the sort of synthetic user kind of sense. So we thought very hard, okay, well, how do you bootstrap this? How do you incentivize this? And we came up with like a specific mechanism, which we call proof of active agent, to do that. And so I'll walk you through this on a high level. But before I do that, let's be concrete about like a use case, because then it should make more sense. So we heard a lot about prediction markets. I like to have contrarian views. The other thing I believe in is prediction markets aren't actually for humans. I think it's a bit of a not so great idea because no one actually, frankly, does it. Probably none of you have ever done it. Maybe 5 of you because you're actually researching it. But ultimately, I don't think we're there to click around on interfaces. This is my second slide, right? Like this interactive paradigm where we just sit there and like do things. No, you want to be in the sun. You want to spend time with your loved ones. You want to do exciting things, right? You don't want to hang out with a prediction market. That doesn't sound very compelling. So, like, let's be real, right? So then the question is like, okay, but we need prediction markets because then we can get more exciting mechanisms. So then the question is, how do we get there? Well, we just make machines do it. I mean, that's how we do it for a lot of problems, which we don't want to do. So let's create. Now, the thing is, with a prediction market, if you just go and say, okay, well, company A does prediction markets now, well, that isn't really a prediction market. That's company A providing a prediction service. That is not the same thing as a prediction market, which is like has to be open by design, right? There have to be different economic actors with competing incentives, blah, blah, blah. So we basically said, okay, well, let's create, like, smart contracts already exist. Smart people have created them, right? No one uses them, or very few people use them. Let's use them, and let's just give synthetic users on top. Let's incentivize autonomous AI agents to actually be the users of these smart contracts, rather than waiting for these magical humans to appear to do all this stuff, right? And so basically we did that on Gnosis together with like a whole bunch of teams. Like one of them is here, Polywrap, Gnosis, Clarus, Napta, you name them all. And basically the result of this is now that there's these 4 different types of agents running, forming effectively an economy because they trade with each other. They trade in the prediction markets, but they also trade with each other in terms of information and using each other's services. And the end result is that we're increasingly getting better at having the purely end-to-end AI-based prediction markets where the question is generated by AI. I'll get to this later. The traders are autonomous AI agents that use basically models, and RAG is the technical term, but like basically real-world information complementing models to make predictions on these events, which are quite timely. And then what you have is basically these kind of markets forming where the, as we heard now several times, where the, if the markets are good, where the price of the market effectively reflects the probability of that event happening, right? So these are binary markets at the moment. So this is an agent economy, and so coming a couple of quick points, just like there's a benchmark, you can go on Hugging Face, there's people running these agents, there's lots of contributors, but coming back to this thing, how do we get more and more participation there? Well, we use crypto incentives, right? Like one thing crypto is clearly good for is to incentivize users to do certain things. Now, often we get it horribly wrong, but if we get it right, then we can basically dial in usage of like a protocol. That's literally what we're doing here. Like we're basically defining KPIs on chain, which these agents have to hit in order to unlock staking rewards, and we call that proof of active agent. So the way this works a bit is you rock up with some model, you pop that into your agent, which I explained earlier. You define these KPIs. In this case, they're around interactions with those markets. You get these useful outcomes, which are these markets. Now you get two other cool things for machine learning folks. You get a lot of new data, because basically what actually happens, like technically under the hood, is that models talk to models. So you get and there's some new data coming in from the web. So you can technically use this to build better models, which could be much more real time than the models which large providers have. Now, this is red because we're not doing it yet. If you can help us do it, let's do it. But if you wanted to do this, conceptually, it looks like the circle. You come up with your goals. So this could be, I want to basically ensure that at any given point in time, someone is liquidating my markets on Aave, let's say, or some whatever lending protocol. That's more or less a solved problem, but sometimes there's weird edge cases. So you could come up with these KPIs, where you then develop a bunch of agents and a matching staking contract on Olas, and you literally put these incentives there. Again, this example is a bit construed because it in itself has an incentive already, but you could, carry that example to another use case like prediction markets. You can carry it to any kind of use case where you want to basically incentivize participation of synthetic users in whatever you're doing on chain and create effectively a mechanism, right? And now for the economic audience, you effectively, if you do it very well, you're creating a mechanism where like the optimal thing is sort of implemented by having these literal agents participate in this game, and the smart contract kind of functions as the incentive medium. This is from my, this is where the presentation goes a bit unrelated to specifically the point I wanted to make here, because I had this from earlier in the week. But just to repeat the point is, if you go back to the very first slide, let me see if I can go back to this. If you go back to here, the problem with this world, if you want to have everyone have access to an agent which they fully own and control, or multiple thereof, that does arbitrarily useful things for them, the problem is really around data and training second, in my opinion. I mean, not just my opinion, but basically the training is expensive and all, but it's doable. The data is the problem. Now, if you think about creating, again, one thing which crypto is very good at is incentives. So if we manage to create meaningful economies around use cases where we can create data that we then get as a byproduct of actually driving some end user benefit which we want to drive. So in the prediction markets, those were the markets, and you get these kind of pairs of prompts and predictions as the synthetic data. If we can generate a lot of this, and if we can basically capture this data in such a way, and this is theoretically definitely possible, practical, a couple of tooling is missing, but basically if we can capture that data and then use for our own training runs, so that, for instance, OpenAI doesn't have that data, then I think we have a chance to start bootstrapping ourselves to initially, better open source small models, but maybe ultimately to better open source large models. And that's sort of, I guess, like the more AI contribution, which we're hoping to drive here by incentivizing agents to work together. So yeah, that completes this part of my talk, and I think the idea was to give you a quick taste of what could be interesting agent economies outside of the context of governance and prediction markets. I think there's very interesting things around papers emerging around simulacra. So the most recent one was one around hospital of agents, where basically people in, I think, either Berkeley or Stanford, this one, managed to create autonomous AI agents that are on par in terms of like performance around certain medical benchmarks with humans. And really the constraint here is to just run this longer, because basically, you know, they have a certain research budget and then it runs out, and then that's where the benchmark ends. If you can keep running this for a year or 2 or 3 and keep improving the models, that's the way to go. And then obviously, maybe we'll replace some researchers with agents or complement them. And there's use cases around definitely the whole entertainment space. The last point I'll make is, if you think back to this example of Bo, which you, not example, the body of work you presented, I think this has an immediate application here, because you could quite literally come with us and design like a staking mechanism which tries to approximate some of the game dynamics which you're trying to induce. And then if you think about the governator and the prediction markets which I mentioned earlier, we now have coming up a new type of agent economy which will sit sort of between those two, and collectively the three, I think, could create a system where at least governance, in the sense of like having more information around the decision making when we vote, could be
That's so exciting.
relatively solved.
Don't mind that. Continue, please.
Well, we can help a lot there, I would say. And in terms of like you building agents either that are like the governator, a delegatee to which we can delegate our tokens, or one of those single agents which actually represents you. If either of those two are something you're toying with or want to do, come talk to us as well. Obviously, again, Olas is not like, you know, we're co-contributors to Olas. We're not building all these things. We're just kind of putting a bunch of tooling out there. We're helping people drive their use cases forward. If you think that might be a match for you, let's talk. And that's it.
Amazing.
Any questions? I know we are late in the day, but do we have any questions?
I'm trying to figure out what order to go in. Hopefully nobody else has questions. I'll ask a really quick one, and then I want to follow up with another. Do you think that most of the useful dynamics that you get out of agents will come from prompt engineering, from like single shot prompt engineering, from prompt chaining, or from something maybe deeper like an architectural change?
Yeah. In which time frame?
Yeah.
Let's say in the next year.
Okay. Well, yeah. I mean, you should start with the most basic form of prompt engineering, and then work yourself to more complex types like chain of thought and whatnot. Actually, the Polyverb team contributed a lot of like these kind of tools to our stack. Lots of other teams did, and you can see them on the benchmark in the context of predictions, like what works well, what doesn't. I think basically what everyone wants, again, like I don't know if it's obvious to people, but like ChatGPT in a sense is like some sort of, I mean, maybe not for all, we don't quite know, but certainly it's basically just a large file with weights, and then like you're kind of prompting it. And what you really want, like, and basically what people then do is they build these contraptions on top, including us, where there's a whole bunch of rules here. You prompt this thing. Maybe this thing prompts itself ultimately, but you have effectively the set of rules and this rather request response kind of machinery, which obviously is like very good at predicting the next token, right? And here the token is the AI token, not the crypto token. Now, what everyone wants is like in an ideal world, right? We have like some sort of new thing, which sort of, I don't know, doesn't really have much on top at all. But effectively, you want to subsume as much of the rules in here to basically have it be part of the model, or at this point, more like an agent, which means you want to have like capacity to have like memory and things like that and other kind of things. So these are these architectural changes people are doing around their models, and we're not the experts there by any stretch of the imagination. But like clearly that's desirable from an architectural point of view, because this is sort of, you know, a halfway house. But that's what we've got. So right now that's what everyone's doing, including OpenAI.
A quick comment is that you're also in a room. You're in a place filled with experts on preference elicitation. So there's a couple of people here to totally steal ideas from, because like the binary choice isn't going to be nearly as informative as some of the
totally agree.
they'll throw.
So that would be directed back at you and all the others in the room who can do that, because I ain't gonna do it, but it needs to be done. Yeah. And so if you're like very keen about this, we have like a whole bunch of developers now who we can match you with to help you like improve Governator. It's an open source software stack. You can run with it. Like you don't have to ask for permission. We can imbue you with our understanding of things, but we unfortunately won't be able to build it.
I love it. And Connor, I know you have more questions, and I think that it's a good time. Can I borrow the mic? Thank you.
It's a good time. First, let's give a huge round of applause for David. And like, how long have you spent building this?
So I've done agents 5 years, 3 with Valerie, and 2 before that with Fetch.
Wow.
Can I ask one more question? Did you get any results from the prediction markets? How good were the agents?
Yeah, so I think on the the prediction tools, so there's the agent which uses the prediction tools. The prediction tools are based on our own internal like human rating better than humans, but the markets aren't quite as good, because the markets actually it's the collection of all the agents, and also you need to basically ensure that like they're correctly like configured in terms of like you want to have enough trader relative to the depth of the liquidity and blah 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 blah. So we're still like working basically on solving that. But there's a ton of data now, various Hugging Face spaces, like these are these basically thingies you can look at, dashboards, where if this is an area where you want to contribute, like we have all the actionable insights, and it's actually being like iterated on every week. So yeah, it's definitely going in the right direction.
Thank you.
Awesome. Yeah.